We don't have time in the prac to go through the full experience of what I wanted to do today was to build a koala image recognition system, but we'll at least get to try out the different components of that. Yeah, just given the amount of time that it takes to train the systems to get adequate performance, let alone the preparation of the data. It's not really possible to do all of that in 2 hours, so we'll have a look at each of those steps using sort of existing either pre-labeled data or pre-trained systems, and hopefully you'll see what it takes to put together a system to build culturally relevant AI. So we saw Michael demonstrated the Hawaii app in the lecture. It's an image recognition system that has been adapted to Hawaiian language. It's essentially an object detector using the COCO dataset. And then it has a translation kind of layer on it where the objects are detected in English and then the results are translated into Hawaiian. Something that we'll consider in today's session is how we can also build systems that detect objects that are specific to particular contexts, so particular cultures, particular language communities. And we'll see how the bias in existing AI can hinder people's uptake of this sort of tech. So the first thing we're going to do is to have a look at Hawaii again, and then we'll fork that and adapt the language content in that app to our own situation or to a language of our choosing. Janet's just messaged to say that my audio is very quiet. Test, test, test. Any better? Turn off the Zoom automatic setting. Okay. Crank it, Janet. Put me on the loudspeakers. Okay, so starting with the Hawaii app, if we go to the GitHub, let's share that with everybody. Go to the GitHub repository of the original code. I'll get some screen sharing happening. Hopefully everyone has a GitHub account. So the first thing you can do is to sign into GitHub and have a look at this repo. It's very minimal bit of code. So the background to this is it's a prototype of some AI that was developed through a series of Indigenous protocols and artificial intelligence workshops a few years back. by a group of engineers, language activists, and cultural advisors. So it's a demonstration of some code, an image recognition system, which you can use either on a desktop or on a phone to identify objects. And it's been adapted to Hawaiian language by a translation of a dictionary file. So there are a couple of ways that this app can be repurposed for other communities. Using the easy method is to remix it using glitch.com, but we're going to go for the slightly more advanced method of forking the project on GitHub. So it requires having a GitHub account. Hopefully everyone has that already. And then the process is to, we'll follow the steps on the README. Fork the project, and then we'll set up our own version of it to publish the code using GitHub pages. So it's a web browser application which there's not much to it. There's an index file and some JavaScript and this dictionary.json file. And the dictionary.json file is where the translation happens. So the terms translated or mapped between the English object name that's detected through the system, and then on the right-hand side of the mapping, we have the language content. So we fork it by clicking, once we sign in, we click the fork button up the top right-hand side. And then you should end up with your own version in your repository. Once you have that in your account, click on Settings and scroll down to Pages. So here, set the source to main and set the folder to docs and click Save. So mine is already set up. Just check that yours is set like this as well. So main, docs, and press Save. So now that the code is ready to be published whenever you make a commit to your fork of the code. And something that you can do to trigger that is first to delete the CNAME. So if I'll just go back to Michael's original code, in the docs folder, there's a CNAME file which has an alias or a web address in it. Now this is going to confuse the page building on GitHub because that name is already assigned, so get an error if we try to publish our version of the code with the same CNAME as another version of the code. So the first thing you can do is to click on the CNAME and press delete. You could add a description in there and then press the OK button. So it looks a little bit different on my example because I have already deleted this. So once the CNAME has been deleted, you should get a commit message at the top of your repository. And then if you go to the address of your username.github.io/Hawaii, it should show you the app. Go ahead and link to that in. Here we go. Now, this app will first prompt for permissions to use the camera. So you need to do that before it can work. Press allow, and there we go. So give me a thumbs up when you're at the point of having the app running in your browser. Yep, cool.
Can you just pop back to that github.io part, that last step there?
Yep. So I'll just put the address in the chat. It might be easier to get it out of. So it's also down the bottom of the README, but they've missed the actual repo name suffix. So it should be your username.github.io/hua underscore, so HUA underscore KII. So mine looks like this, also in the chat. Cool. Now it does take a moment for the app to sort of load in the browser because it downloads this Cocoa model that was talked about the other day. But once it's in the browser, you should be able to click the camera icon, and get some kind of detection, at least of yourself. And then if you go to that address using your mobile device, then you can use that to kind of point around the room and get object detection for things like cups, keyboards, monitors, all the things that are close to hand. Is that working for you, Hunter?
Yep, I got it working.
Cool. Okay, so once that's working, then we can go into docs and have a look at dictionary.json. And so one of our tasks here is to edit this and try adapting that for another language. So that's kind of easy way to do this might be to edit that file, copy the text, and then I'm thinking like a lazy approach might be to open up a text editor. So I use a program called Sublime Text. You could use something like BB Edit or possibly even Text Edit. One of the advantages of Sublime Text or BB Edit is that you can perform multiple line selection things. So you can select all of the words in a group So one approach might be to get all of these English words, copy them out, dump them into Google Translate, and then we'll choose a language that we want to translate them to, and then we'll bring that in and repopulate. So if I was to do something like to isolate the English words out of here, if I find all of the quotes, colons, and spaces, and work back from there. So here I have all of the English words selected. We go to Google Translate, paste them all in, and let's see, choose a language. Hey, there's Hawaiian. That's interesting. I wonder how similar they are. Yeah, okay. Something is different there. Let me try. I don't know any other languages very well, so it doesn't really matter. But let me try Greek. Now, if I copy the Greek, the results of my translation, it looks like there's some. No, maybe I'll get a different language. I want something that's pretty closely mapped. There we go. If you happen to know another language, that'd be great to use that. So I've copied the translation, and now I can go back into my file, and using the multiple character selection kind of technique, I'll paste the results. So I've just updated the Hawaiian to an Albanian translation. So then if I copy the whole text back into GitHub, I can commit those changes. Once I've committed the changes, it'll take a minute or two for the page to be rebuilt. Can't remember where there's a section in GitHub where you can see what the publication, whether the publications happen or not, but yeah. So this hasn't picked up those changes. So I need to go into the either developer settings or maybe like a clear history, possibly like a force refresh. I might just go and jump over and use a different browser. Oh, right. So the language that I chose, it hasn't. The Albanian word for person in Google Translate is person. So not a really good example. Let's try Portuguese. All right, that's looking a bit more promising. So, again, copy the translation text out. Use this magic multi-cursor stuff to replace the text in the original. Copy that back into my Waikiki. And save it again. Okay, how did I get all the words between that on the left? So using Sublime Text, I can do a replace. So find replace, and then I can either use regular expressions with this button down here, or I can search for something that I can see as a pattern in the text. And so I could either search for like a space and a quotation mark, but that'll also pick up this space and quotation in the middle of each line. So when I was looking at it before, I saw that we've got this pattern of a quote, a colon, and a space, and I could add the other quote on the end of that. So this is identified, or it's matched all of those middle sections, and then I can use find all to highlight all of those or to select all of those. And then because Sublime Text allows me to have multiple cursors, I can, whoops, I'll do that again. So find all, I just cursor back. So I'll use my back like left arrow thing, and that's taking me to the inside of the quote. And then I'll use, oh, that's interesting. How did I get that before? Command and Shift to jump back to the beginning of all of those, and then Shift and right arrow to come back to the beginning of the word. So I'll find all based on that pattern. Shift Command left arrow to select back to the beginning of that text, and then Shift right arrow to select one character forward. So another approach would be like regular expression matching, might be more a simpler way to do that. Yeah, my regular expression stuff off the top of my head's not so great. Nah, I have to play around with that too much. Yeah, okay, cool. What's the character for the start of line in regular expressions? My muscle memory for that stuff's not so great. Oh yeah, okay. So start of the line, maybe like space, 2 spaces, and then the quotation mark that'll get us to the same situation. And then you can use those multiple cursor movement things to bulk select stuff. All right, so if I now, what did I end up with? Portuguese. So I'll try reloading that app and see if it detects me as a person in Portuguese. Ah. All right, it worked. So that it doesn't recognize my cup. It's a bit sad. Just going to try that on my phone and see if it picks up the cup on the table when there's not a person behind it. Hey, yeah. Okay, so it seems to have recognized it here when it's on the table, not being held by me. Ah, cool. That's one less into. So there's a few things that this prototype highlights, and I guess that's the point of it being a prototype, and it's not a production ready app. It's been designed to make us think about AI in this context. And that's one of the first things that becomes apparent is that it's not going to recognize everything around the place. It's limited by the objects that it's been trained upon. And so while the app recognized my coffee cup on the table, it's probably not going to recognize this kind of crazy handcrafted cup that's sitting next to it. It's made by some artisan somewhere because it doesn't really fit that paradigm of cup that's likely to be similar to the images that it's been trained on. So the application of the tech in different contexts is going to, like some things it's going to work pretty well on, some things it's not going to work well on. And so like Lucinda just said in the chat as well, it's very hit and miss. Depends on whether the books that you're trying to recognize, how closely they match the images of books that have been used in training. And so the other thing I was playing with yesterday was, so using common, like an image recognition app off the App Store that uses a very powerful image recognition system called YOLO. I tried using this YOLO image recognizer to detect a koala, and it couldn't do it. It recognized the koala either as a cat or a dog, or in some cases a bear. But as everyone knows, koalas are not bears. So I would consider that to be a fail on all accounts. So I was hoping today to spend the time building a koala recognition app, but given the amount of time that it takes to actually do that, we'll work on some of the parts of it. So it's this Huaki shows us that while we can really quickly set up a translated app at the level of the word translation of the lexical items, it's not necessarily culturally appropriate or culturally relevant. So to be really culturally appropriate in developing AI, we need to develop our own systems and develop systems with communities. So even to see that the dictionary, which comes with the original Hawaiian dictionary in the repository, has very different terms for some of the words than we get if we use Google Translate. So this is very clearly being written and created with Hawaiian language activists or language knowledge holders. And so they've been very specific about this in a way that we don't get from the generic Hawaiian dataset from a source like Google. Okay, so for assessment, one of the first assessment things is to talk about or to build the app and translate it into a language of your choice, and then submit the link to your code. So we can be able to see them here. So send us in that link to your code. If you want to send us in a screenshot of a result, that'd be great too. So the big steps to develop our own systems are primarily around data. So we don't need to get to the point of building our own architecture, machine learning or AI architecture. There's some really good stuff around that's easy to use these days. But the sticking point is having data that's culturally relevant. So the data that the Huaki app is trained on is this Cocoa dataset. You can have a look. There's the link to that. You can click on these categories to see the example images that have been used and the way that they've been labeled or annotated. So this data set has been labeled with polygons. So there are polygon shapes in the images, and the labels for each of those terms or categories or concepts are shown. So we have here in this image that we're looking at, we have cows and we have a dog. So each cow has a polygon outline around it. So this is a particular way of doing annotations. Another approach is to just draw boxes around things. So the polygons can be more accurate, and the boxes may be quicker to label. Hey, cool, Hunter, it worked. Nice one. So if you flick through this Cocoa Explorer, we can see that the kind of data that it's got. For some things, it's like the shape of a bus is fairly universal. But some other shapes, and particularly if you get into smaller objects, can be much more locally specific. So what we want to look at next is how to label your own data set. Say if we wanted to build a koala recognition application like this. So there's no koalas in here at all. What's this thing? So there's bears. If we look at the bear category in Cocoa, It's fair enough to understand why a koala would be recognized as a bear, because they do share similar sort of features: bear, cat, dog. But if we want to be more specific, then we've got to build our own. So the steps are around accessing or creating source data, so images to use in training, and then preparing them and labeling them. And then we can also do some data quality control. I've got these steps a little bit back to front in the prac notes, but anyway. So here's another data set that is worth looking at, just to see what these image recognition systems are popularly or commonly trained on. But this is a data set of 60,000 images. They're very small though, 32 by 32 pixels. And it's only 10 classes. So for detecting whether it's a truck coming towards you or a dog, then this data set might be satisfactory. But for anything more discrete, it's not really so suitable. There's another version of this which goes into more classes, so we have 100 subclasses within a group of superclasses, 20 superclasses. But still might need to be locally adapted. So these can also be used as a basis for fine tuning or fine training. So we will get a chance to look at that later. So say we want to build our own koala recognition system. Maybe a good place to start would be to have a look to see if Google Images has any decent koala photos. And lo and behold, it does. Lots of different poses, different like headshots, body shots, sleeping koalas, koalas with people. So this looks like potentially a decent data set to train a system on. The challenge here is how do we get our hands on it? So we could write a custom web scraper. I just came across this website called imagedownloader.com, which seems to work reasonably well for downloading Google images. So I can go to that, type in Google, select the Google option, and I can type in koala here, press search, and it'll go and crawl Google to bring down some photos. So while we won't be actually building the koala detection system today, one of the assessment items is to manually label by drawing boxes around the koalas in a bunch of images. So we'll first download a bunch of images and then we'll have a look at the manual labeling application. So we type in koala to Google, just sort of quick verification that they tend to look like koalas, and I think we only need 10 for the assessment, so I'll just download these initial results. So this is downloading while we wait for that. I've got a few too many than I need. So the image labeling, so typically a step before we actually get to labeling is to conform the sizes. So when we use the detection, the training code, we want to have consistent sizes for our training data. So depending on our labeling process, we might need to resize all of the images first. We're going to use a system called RoboFlow, which does that for us, which is kind of nice. But if we were to use something like fast annotation, one of these fast annotations or label image, these are tools which you can install on your own machine compared to MakeSense or RoboFlow, which are browser-based tools. Then you might need to conform your images prior to using these. So fast annotation, single object, and they have another version called fast annotation multi-object. Fast annotation tool and label image, they're all programs which are open source tools which you can download and build on your own machine. So this one, fast annotation single object, claims to be suitable for annotating around 6,000 images per day, which is quite a claim, and I think might be unreasonable for most regular applications. We'll see later on when we start to train a system, we're going to use a raccoon dataset, and the person who labeled that said it took them 2 hours to label 200 images. All right, so my image downloader thing's ready. I need to allow it to download, and then I should get a folder called download all, and there's my 50 or so koalas. Oh, it's cute. Yeah. Okay, so give me a thumbs up when you've got your images, and then we'll look at how to label them. So we're going to use, I'll just show you this MakeSense app first because it's pretty neat. I think, did I have it still open? No, probably not. So MakeSense is a free system. You just click get started and drop a couple of images on. We want to do object detection, and we make a label. So if we're only going to build a system that recognizes koalas and exclusively koalas, then we only need one label. But say if we wanted to detect koalas and kangaroos, then we would insert another label there. And so it makes sense. We draw boxes around the koala. Probably want to get its ear as well. And select the label. Done. Second one. draw boxes around the koalas. And hey, it already knows that I want to label it with koala, and so on. So this technique uses boxes. If we wanted to do polygons instead, we would change the tool down here and draw our polygons around the koala, including the foot sticking up in the air. Polygons helps to be reasonably precise. You can add polygons into the continuum after the effect if you need to fine tune. Okay, so whichever way, doing bounding boxes or polygons, you can label the images. Go back to the rectangle for this guy. Now, depending on the image or the object detection system that you want to use, then, oh, did I forget to save that? Great. Box that is. Depending on the system that you want to use, some systems work with rectangles only, some systems work with polygons only. So it helps to know which system you're going to build for before you start doing your labeling. So once they've been labeled, they can go to actions and export annotations. And depending on which system, I will either export in YOLO format or XML format or CSV. And so I'll just download in this YOLO format. You can see the format that this website creates. So we're going to use RoboFlow because it builds a data set in the YOLO version 5 format, which is compatible with the training that we're going to do in a moment. Where did that go? So using Make Sense, I get text files downloaded, which are a description of the bounding boxes for each of the images. And it has so the integer at the beginning. So we have the first column is an integer, which relates to the label. So if there were multiple labels, there would be, there might be a 0 or a 1 or a 2 or a 3 here, depending on the label. And then we have our box dimensions. So Make Sense is really nice to use, only that it doesn't export it in the version 5 format. Otherwise, I'd be using that more frequently. So have a look at RoboFlow. So to use this one, we need to sign in. We need to make an account. And for bonus, we can sign in with our GitHub account. So once we've signed in, we can create a new project and we'll give it a name. Add a license if it's appropriate. So the, RoboFlow free accounts, all of the data sets that you create are public. And so if you want to make a private account, a private data set, I think there might need to be an update or upgrade to a different account. And we choose whether we want a bounding box or other type of classification. So that's suitable for what we want to do today. And then the annotation group are the labels that we want to use. And I would upload 10 or so of our koalas. And if we were actually building a real detection system, we probably you'd want to try to get at least 100 or more examples of each object. So if you want to actually kind of come back and build a real detector for koalas later on, see if you can get 150 or more. So they're all done. They're uploaded. Then I can go to annotate. Oh no, what I've got to press finish upload. Sure. So this gives us an option to split the images between our training, validation, and test sets. I think we're going to, yeah, we'll use an automatic. I might crank it. So 80, 10, 10, training, validation, and test. Might even just do 5 tests. So this is going to use 80% of the images for training our system and 15% for validating the system, and then it'll reserve 5% so that we can do some detection on them later. So this information will be saved into a configuration file, which we'll use in our training. Okay, all good. So we can click on an image and we can get straight into labeling it. So same as before, draw a box, choose the label. And then next, there's probably some nice keyboard shortcuts to find how to accelerate that. And you want to make sure that you get all of the koala, not just the face, because it needs to recognize the whole koala. And when they say that good practices for annotation is to even include, to draw your bounding box around occluded areas. So areas that might be hidden behind other objects. Sleeping koala. Oh, that's, this is going to be difficult. So this image, possibly better to not include that top nose. I'm not so sure about that. Possibly even do a separate, I wonder if we can do 2 boxes on that same image. All right. So tempting to. Okay, so there's my data set. It's all nicely annotated. Check my data set information, source images 10 are, I've got 10 images in one class, all annotated. I've got 8 images in training, 2 in validation. Okay, so it didn't end up with any in the test set. So let's rebalance that because we do want to keep at least 1 for testing. So 10 images is not going to be enough to build a system with. You really need to have 10 times this to get some decent results. But for the purpose of assessment, this is what we want to see. So then pre-processing, so RoboFlow has some nice little tools, particularly the resizing. So 416 by 416 is a size that is used in the YOLO version 5 kind of default training code. So that's nice. I can pre-process these, and if you wanted to, you could do some augmentation by making versions of each image with rotation or different kind of brightness or exposure settings, and that can help a system to be more robust to noise. Once it's ready, we'll press generate, and it does those pre-processing steps, does the resizing for us automatically. And so there we go. Now we have a data set. To use that, we press export, and we can either download it or we can make some download code. And so this is the other great thing about RoboFlow, is that we have these different options. And for the purposes of our training today, we're going to look at YOLO version 5 code. So this is a object detection system which is really seriously good. We could either download the data to the computer or we can do show download code. And we'll do this because it's going to be a bit easier for us to access the code, so you don't have to upload it to Blackboard. And we'll also use this format when we do our training in a moment. So this generates a download script, so the curl and then a URL. So that's the URL. I'm going to make that a bit bigger. So it's a download script which has this address, which is to our dataset with a permissions key, access key, and it'll download that to a file called RoboFlow zip. It'll unzip it, and then it'll remove the zip. So we'll see in a moment, we'll use this in a Colab to access some other data and bring that into the Colab. But we'll also use that for the submission or in your assessment. So for the assessment, if you could submit the link to the data set, either as the whole curl script or just that link, that would be great. So what happens if I just browse to that? It should just give me a download. And then in my downloaded data, I have these 3 test, train, and validation folders. And so inside of each, there's my images. And so you can see that they've all been resized to 416 by 416, and they've been squished. So that they're not cropped, they're just resized. And the labels are in the same format that we just saw before. So they're the integer for the label name, and then the coordinates of the bounding box. So that's the same for the different categories. So there's our, oh, that's going to be interesting. He came up in the test set. And then we also have a data, this YAML file, and we'll have a look at that. So the YAML file tells us that we have a training folder and a validation folder, and there's one category, one class name, and it is koala. So if we had, say if there were 2, it'd be something like that. So this is an array of the labels in the data set. Okay, how's that going? So we have 5 minutes break, and then we'll get into training our Colab. Okay. I'll see you 10 past.